Okay, we're going to talk about global. Let's do this. Local maximum, local minimum, global or absolute maximum, and global or absolute minimum. And let's look at this graph. And there's three ways I could ask this question. So I'm going to make a table. What is the global max or min or local max or min? Where is it? And what's the point of it? Where's the point? And I could do that for this graph, and I could do it for this graph. Okay, so now let's explain what a local maximum. A local maximum is a place on the graph that is the highest place in its neighborhood, in its nearby area. So if I look at this graph, right here is the highest place on this curve in this area. If I go to the left or to the right of this place, I go down. So right here is kind of the king of the mountain, the highest place in this neighborhood. And that height looks like it's like negative 0.3 or 2 or something like that. So what is the local max? It is a negative 0.3. Now there's another place where it's highest in its neighborhood right here, and it looks like it's about 2. So looks like there's 2 local maximums on this graph, highest places in their neighborhood. Over here, it looks like it was going to have one right here of about a height of 1, 2, 3, 4, 5, but it doesn't exist there. And there is no other local one, so there is none. Now, back over here, where are these two? Well, one's at x equal 1. That's this one. And one's at x equal 7.5. In other words, there's one at the point 1, negative 0.3, and one at the point 7.52. So if I asked, what is the local maximum? You would give me these numbers. If I asked you, where are the local maximums? You would say at 1 and 7.5. If I asked you, what's the point where there's a local maximum? Then you would give me the coordinates of the point. So know the difference between is, where, and what's the point. Okay? So here, there were none, and so there's no points. Now let's look at local minimums. As opposed to king of the mountain, here, top of the mountain, top of the rolling hill. Looked like there would be one here, but there's a hole in it, so not. A local minimum is a valley, a place where if it was raining, the water would accumulate. And it looks like that one is about, the local minimum's about 2.7. That's the local minimum. Where does it happen? Well, at about x equal 1.5. So the point is at 1.5, 2.7. So if I asked you what is or are the local minimums, you'd be giving single digits for the heights, single numbers. If I asked you where, you'd be saying at x equals and tell me all the places. And if I asked you for the point, you give me the coordinates. On this one, looks like there's a local minimum here. And it looks like it's about -1. Just a rough estimate. Where it looks like it's happening at x equal, about 3. And so the point is at -1, 3. Now, some might think that's a local minimum, but it is lower than everything on the right, but we don't know on the left. It has to be a local minimum. It has to be lower than everything on the left and on the right. Well, it is on the right, but we don't have anything on the left, so we can't call it a local minimum. You might call, and this one, let's see, what else? You might think that's a local minimum, but again, it's lower than everything on the left, but we don't know on the right, so can't call that a local minimum. Now, global max, it is the highest value of, highest y value on the whole graph. Well, this is pretty high, but this looks higher. There's places higher over here. And it keeps going up, but it never, it looks like it's headed towards 6, but it never gets there. That's what the open circle says. It gets closer and closer and closer to 6, but never reaches 6. So there is no global max. So how about on this one? Yes, there is a highest place, and that happens to be 2. It was also a local max, but it happens to be also a global max. It happens at x equals 7.5, and it happens at the point of 7.52. So a global max can also be a local max. Now, let's look for global mins. Well, this is pretty low, but this is lower, and so we have a global min. The lowest place on the whole graph is about 3.8, 2.7. It happens at x equal 1.5, so 1.5, 2.7. And here, do we have a global minimum? Well, it's not there, but this is not a lowest place because there are places lower, but they keep going down and down and down until it disappears. So there is none. Okay? So that's global maxes, global mins, local maxes, and local mins. Just a quick review. To be a global min, it has to be a place where water would collect. To be a global max, if we had helium trying to rise in here, if it escapes, not a global local min. Max. Here, it would get trapped. Here, it would get trapped. So we got a local max, local max. At the ends, it always gets by, so not local or global. Global max or mins. Global is just the lowest place on the graph, if it exists, and the highest place. Could there be more than one global local min? Well, we had only one here. We had two global maxes, local maxes, and you can have 2 or 3 or 4. You can have multiple local maxes and local mins. Global max and mins, you would think probably there's only one possible max, but remember the problem we did with a graph with a bicyclist, how high their toe is from the ground, and it went something like this. Looks like it would always be at the bottom of the pedal, the same distance from the ground, and at the top of the pedal, as you're pedaling, the top would be the same. So it has multiple global max, multiple places where there's a global max, but there is only one global max value, that height. So there can be only one value where what is the maximum? It's a value. It may happen several places, and so there might be several points, but there's still only one global max and one global min. It's the value is singular, where it happens might be multiple places. Okay, that's my explanation of that.